Okay.
Our distinguished guests, Assalamualaikum. Good morning and welcome to the Faculty of Built Environment, UiTM Puncak Alam. I'm Hamiza.
And I'm Hakim.
Our final year master student from Studio Nuansa will be your host for this special session titled On Green Design, delivered by none other than Dato Dr. Yeang.
We are truly delighted to guide you through a session that brings together design, ecology, and innovation. This morning, we delve into green architecture with one of the world's leading pioneers in sustainable design.
That there will be a designated Q&A session at the end of the talk. So, if you have any questions, please hold on to them clearly until the time comes. So, to start our program, I would like to invite everybody to recite a short prayer.
من غزائن رحمتك يا ارحم الراحمين ربنا اشرح لنا صدورنا ويسر لنا امورنا واهل عقدة من السنتنا يفقهوا قولنا علم الانسان ما لا يعلم اللهم ربنا اتنا في الدنيا حسنه وفي الاخره حسنه وقنا عذاب النار وصلى الله على سيدنا محمد وعلى اله وصحبه وبارك وسلم الحمد لله رب العالمين.
Okay, now allow us to introduce our esteemed speaker, who is globally recognized for redefining how architecture interacts with nature and every scale.
Dato Dr. Yeang trained at the Architectural Association School in London and later completed his doctorate at the University of Cambridge. He currently practices with the Kuala Hamza under the Al Hamza and Yeang in Kuala Lumpur.
Often described as the creator of constructed ecosystem, his work integrates ecological system directly into architectural form. With a career spanning over 5 decades, he is celebrated internationally as an architect, ecologist, and author whose research continues to advance nature-centric design.
The Messinaga Tower, for instance, was awarded the prestigious Agahan Award for its pioneering approach to sustainable high-rise design. Another landmark project, the Solaris Tower in Singapore, was honored with the Pan Gold Medal for its excellence in green architecture. Other notable works that many of us may recognize include Swasana Putrajaya, the Great Ormond Street Hospital extension in London, and the National Library of Singapore, to name just a few.
Beyond these projects, Dato Dr. Yeang has received numerous global honors, including the August Parade Award for Technology in Architecture, the Liang C-Check International Award, the Prince Claus Award, and the Merdeka Award. He was also recognized by The Guardian as one of the 50 people who could serve the planet.
And now, it is our great honor to to invite our distinguished speaker to present his talk.
Thank you for having me. It's very nice to be here. I'm going to talk about the work I've been doing for a few years. Essentially, it's about ecological design or green design. The current conditions is like this. Our human society is crowded in a boat, which is the built environment. And the boat is in a turbulent sea. And this is our endangered planet. But once the boat has a leak, and this is a crisis period, to rescue the information and directives, and the action needed is ecology. And the reason is ecology is a baseline indicator of the health of the planet. You need means and equipment to escape. And the process is through the biochemistry of ecosystems to make the built environment a constructed ecosystem, to achieve a nature-to-nature interface. What happened to us? Let's have a look at that. This slide summarizes what ecological design is about. A human society in our built environment, in a turbulent sea, and there's a leak. To rescue, we need information and directives. We need the means and equipment. The information and directives is ecology as environmentology. And ecology is the baseline indicator of the health of the planet. The means and equipment is through biomimicry of the ecosystem to make our built environment a constructed ecosystem. At the moment, the relationship between our built environment to nature is technology to nature, and we have to achieve a nature-to-nature interface. It sounds a little bit complex, but I think this slide summarizes what I'm trying to do in my work. Now, you all know about the ship Titanic. And the Titanic, as you know, sank because it hit the iceberg. And if you knew that the Titanic is going to hit the iceberg, and if you know that right now our built environment is in a crisis, and we don't have very much time left, you should be concerned about not just your own future, but of your grandchildren as well. So if you know it's going to hit the iceberg, then you need to be at the captain's bridge, and you want to take the boat to safety. So now, ecological design for me is the integration of these 5 factors. We start with nature in the middle, then there's human society, there is energy systems, That's our built systems. I don't know what happened to the slides. Oh, okay. The built systems, and then our hydrology. Let's look at nature first. Ecologists sees the Earth as covered by a thin film called the biosphere, where organisms live. Within the biosphere, there are units in nature called ecosystems, consist of communities of plants and animals, and habitats, and the population of species and organisms in the soil. The ecosystems exist in the biome within the biosphere and consist of biotic, which is the organic constituents, and the abiotic, and acting together to form a whole unit. But within the ecosystems, there are many processes that take place. And we cannot see them. That if you look out, you see trees and grass, but there are a lot of processes that take place, and we have to be careful we don't damage any of them. So back to this diagram, let's look a little bit about ecology. The process of biomimicry means is the imitation of biological systems. And with biomimicry, the biological system for me is the ecosystem. This is a prototype. And from there, we design the built environment as a constructed ecosystem. The process of biomimicry is through replication, emulation, imitate, augment, and supplement to create human-made hybrid ecosystems. I'm very sorry that all this, there are a lot of words, a lot of theory here. But that is why it's very important for architects to become eco-literate. And there are a few schools not that many schools of architecture in the world that teach ecology. And so I started to look into how we can create constructed ecosystems. If you look at a city like Kuala Lumpur or New York, it's mostly abiotic. Abiotic means it's mostly inorganic. So then where is the organic component? So we need to bring together the organic and the inorganic to create habitats. So our work starts to look at how can we create habitats in the built environment. You can put it all in one location, as you can see in this diagram. Or you can have a spotty relationship. I don't know what's wrong with my slides. As in this diagram. Or you can have a stepping stone relationship. As in this diagram. And you have a spiraling interconnected relationship, or you can fully integrate vegetation into buildings. And the last pattern is the spine relationship. I don't know why my slides are all mixed up. Maybe this might be better, I think, than I'm used to. Doesn't work. And then within the buildings, we create habitats as well. Green walls, green, vertical green areas, green sky clouds, and so forth. But connectedness is very important, so we should try to connect the greenery both at the ground plane and with the vertical. So in nature, everything's connected. What human beings do is that we chop up nature, we fragment it. And so with these ideas, I started to design experimental buildings. This is the Eden Tower that we designed in Singapore. It's not built, but it started to look at connectivity, how vegetation could be linked within the building. These are the plans of the building. The idea was to have a ramp, a vegetated ramp that goes all the way around to the top of the building, and in between would be the usable spaces. We designed this as a cultural building with museums, with exhibition areas, with cafes and restaurants. And this is the model that we built. The idea was to have sky courts within the building, and that as the ramp reaches the level of the adjoining building, we bridge across to the roofs of the adjoining buildings and we green it. So this was the idea of how to green the city. But it's just an idea, it was not implemented. In PJ, we designed a data center. Here we had green walls that climb up the facade, goes around the sides of the building to the back and down again. Now, when we design, we look at a site. We ask, what sort of site is it? Is it a pristine site? Is it partially disturbed, significantly disturbed? Has the land been totally cleared? Is the site urbanized? If it's a pristine site, like a traditional forest, we should leave it untouched. If it's partially disturbed, we should repair and regenerate. If it's significantly disturbed, we have sometimes we have secondary vegetation, we should regenerate. But if the land is totally cleared, we have to rehabilitate and revegetate. And if with an urbanized site, like in a city, we should create habitats within the site. So the idea of a ramp building with ramp vegetation was an idea that intrigued us. So the idea was to have a ramp that climbs one floor with every facade, and in this way reaches the top. So this was our conceptual drawing that shows the ramp and the vegetation on one side that goes all the way up to the top of the building. Now this walkway is important because many of my colleagues who do vegetation buildings, we cannot get access to the vegetation. You have to go through the user spaces, and that irritates people no end, and it's very inconvenient. So what we've done is that we put the vegetation as a ramp, and next to it is a walkway that you can service it. And so here it is completed. You can see the walkway, people servicing the building. This user space on the inside. But so this walkway, if you stretch it out, it's 1.3 kilometers long. So we call it a linear park. But it is monotonous. And what we did was to create sky courts at the corners. And so that the corner would open up into sky courts. And the plants do more than just are not decorative, but plants absorb pollutants from the air and they try to remediate the pollutants in the air. And so this was one of our early green projects. This is built in the Bina district in Singapore about 10-15 years ago. Then I have a series of mid-level gardens. This is the mid-level. And then this is a roof garden. And between the mid-level and the roof, there's a series of other gardens as well. About 4 other gardens, and it's connected to the ground, but to the adjoining plots. These are the sky plots. And this is where you can go out to get fresh air, you can look out, you can have a view there, have a cigarette if they have to. And so these are sky coats at the corner of the building. And then we bring the vegetation on the right-hand side all the way down to the basement. And this is where it goes down to what we call Ecocell. And all the way down to the basement where we have a living machine or a biosphere to bring the water back into the ground. But the building is actually 2 blocks linked by an atrium. Above the atrium is the glass roof. And on a normal day, if it rains, the glass is closed. It's automated so that when it's not raining, it opens up. So you can see on the right-hand side, the windows open up. And this is looking up with the glass roof. And on the right-hand side, in the red box, is the atrium. The atrium is not a fully air-conditioned space, and there's a cold air blown into it. This is a simulation of the daylight entering the floor. Not a very good design because the floor is too deep. In Germany, no desks are allowed more than 7 meters away from the glass. So in Germany, most buildings are very slim buildings, about 40 meters from glass to glass. Here I have more than 40 meters, which is not ideal. I should redesign it in another way. But there are some experiments here. You can see the white square is a slot that cut all the way down to the bottom. I call it the diagonal light shaft. And you can see the diagonal light shaft on the right-hand side. On the left-hand side is the view looking down the shaft to the street level. This brings daylight into the inner parts of the floor plate. And then from the floor and the lower floor looking up, this is what it looks like. Looking up into the floor plate. The 2 blocks they're actually 2 blocks, A and B. With the atrium in between, they're linked by bridges. And this is the bridge that links the 2. The Singapore equivalent of the Green Building Index is called the Green Mark. And the Green Mark criteria is that you've got to have the green ratio of 6. Means the greenery in the building should be 6 times the area of the floor, the footprint of the building. And here we got 12.2, so what it means is that rating systems are just guidelines which you should try and exceed as much as you can. So now, biodiversity. And if you try in the design, you try and see if we can enhance the biodiversity of the site. So this project is in Putrajaya, and the land has been totally cleared. It was just brown soil. So we need to rehabilitate and revegetate it. The building was completed about 5-8 years ago. And this is the facade facing the square. What we did was to create a series of sky colors in the building, and this is the pattern we used was this, where we had a series of sky colors, which are not exactly linked. It is like a stepping stone. Of course, the ideal vegetative pattern is the one on the right, where it's linked. By being linked, there's a greater pool of resources within the green area to be shared among the species. And by having a larger pool, it engenders a much greater opportunity for survival, with the other earlier three patterns, like the stepping stone, and this dispersed relationship and the centralized relationship do not engender. And so this was a scheme where we did not link it, and we didn't have opportunity to do that with design. So the pattern is the patchy dispersed pattern that you see on the right-hand side. So one of the things we did was to look into what are the existing fauna species for that locality. So this was the survey that we did. And we want to bring the fauna species back into the site. Kuala Lumpur is photogenic for 2.9, 2.8 degrees above the equator. So you can see the equator there. The green bars indicate the diversity of location. As you head upwards, you get lower and lower biodiversity. Beijing is 29 degrees. London is 52 degrees. The site is an irregular site. And our building form is essentially two chevrons, two V-shaped buildings. We could not make it symmetrical because of the shape of the site. But on the upper bar, you can see the red strips which indicate the habitats that we locate within the building. And so that's the first thing we do when we design a building. We decide where we're going to locate the habitats. As you can see between the buildings, we have a promenade. And within the promenade is a planted area. So these are the habitats within the building. We look at what species of fauna we want to bring back to the site. Remember that drawing that shows the ones we want to bring back. And then we start to look at what flora species will attract the fauna. And we look at the interaction between both of them. And that provides the basis for designing the habitats. So in a nutshell, this is our biodiversity approach. And not only to bring the vegetation to the ground, but bring it all the way down to the basin as well. And so these are what we call eco-cells. Eco-cells is an idea we developed or we thought of 5-8 years earlier when we did the competition for the Kowloon waterfront. And the red squares are where the eco-cells are that brings the vegetation from the roof down to the basement. And these eco-cells do a number of things. It brings vertical integration back to the ground. It provide opportunities for rainwater harvesting, brings natural vegetation into the ground in daylight, and at the bottom we can have a living machine. Then we started to experiment with the facade. The conventional facade for sun shading would be horizontal roofless. And we just said, let's try something different. So here what we did was we took glass panels for sun shading. The glass panels have fitted patterns on it. And it is separated from the inner facade, so it's essentially a double-skin facade. And the glass panels are not butt jointed. There's an air gap in between so that air can flow through. And we wanted to have a cultural reference to the building. So we took the idea of the royalty and took the socket pattern as a pattern for the glass. And we shaped the building with faceted so that it looked like a jewel along the boulevard. So this was our idea. For the west side, we angled the glass to face the sun. This is the walkway between the outer skin and the inner skin. And this is what it looks like in the walkway. And looking out in the glass, this is what it looks like from the glass. So this was an experimental sun shading for us. So does it work? So these were the figures we got. The average office building in Colombo uses about 230 to 250, indicates 210 kilowatt hours per square meter per annum. But with this fitted glass sunshade, we reduce it by about 38%. We got it down to 136.18 kilowatt hours per square meter per annum. That's about 30+% reduction, but not ideal. So this is the west facade. And then we start to look at the reason why the buildings were shaped in that way. You see, there are two axes. The long axis is the one where the boulevard is, leading to the Prime Minister's office. And then our site is at an angle. The second axis is between the plaza, which is designed by Mr. Hijaska's Jury, and at the bottom is the Millennium Monument, which we designed a few years earlier. So this is the axis from the plaza on the left-hand side down to the monument. And on the far right is the famous Sri Wawasan Bridge. So you can see the plaza, the PGH building on the right-hand side by Philip Cox, and the access going down to the monument on the left-hand side. We designed the monument a few years back for this building, and you can see on the right-hand side the monument is by the waterfront, and the Prime Minister's office is on the top with the plaza below it. And next to that is the Ministry of Finance buildings that were done by GDP. And we wanted to have, again, a cultural reference for the monument. The idea was to take our national flower, the hibiscus, and to shape the ramps like the leaves of hibiscus. So this was our cultural reference. So it's important for us when we design a building that there should be a reference to its locality and its context. So we start to look at a biological structure and look at the urban sites. This is the next building, is the skyline building, which is completed now. The pattern that we had was the tree pattern, and the idea was that the tree had a series of sky courts. And when we designed the building, the first thing we did was to look at its ecological context. It's right in the middle of our low post, so there is no immediate vegetation. And what you can see on the bottom square is the green areas, in which ecology gives us clues on what species to bring back. So the building is basically a spine that we have in the middle with the sky courts at the edge. And these are we start to look at what vegetation is put into the building and what are the faunal species we want to attract. And so for the lower floors, we wanted to attract dragonflies and butterflies. For the middle floors are the songbirds, and the upper floors are the migratory birds. We wanted to make the top floor into a pleasure zone, a happy zone for people. And we had a number of pools. The top floor had 4 pools. We have the number 1, which is the lead pool. Number 2 is the children's pool. Number 3 is the family pool. And number 4 is the jacuzzi pool. 5, 8, and 7 are decks for entertainment. And 6 is an open air amphitheater. So the whole floor is for entertainment, for recreation, and for enjoyment. And that's what we try to do with our projects, to try and give pleasure to people in the design. But if we go back another, maybe about 10, 15 years earlier, this was the building that we did in Tamandu. At that time the client was IBM, and IBM, if you remember, the logo had blue lines, and so the horizontal lines were blue. And we wanted to have a continuity, but we couldn't achieve total continuity. There was a stepping stone relationship in the sense that the vegetation is a series of planters which are linked by trellises. And then a few years later we did the Boston building where we had a series of sky courts at the corners which are not connected. And around that time we started to think of what does it mean to design a bioclimatic skyscraper. So the key factors were that the lift lobby is naturally ventilated, the toilets, the staircases were naturally ventilated, and they're not in the center of the building, not the central core position. And so we started to look at how the core position can improve the thermal performance of the building. And the right-hand side is a diagrams of different core positions to the side, to the end. But we found that the core position on the east and west side had the lowest air conditioning requirement. And so this justifies the shape of the building. At that time, we also did the Messenger building. We wanted to create multi-story sky courts, which are about 3-story. And this was finished in 1992. The owners didn't really look after the building. They didn't believe in spending money on the building. And so we went down to material issue. On the right-hand side, you can see the plans for the building. You can see the sky courts. I climb all the way up the building. So that again, the principles of a biodynamic skyscraper is there. Natural ventilated lift core, staircases and toilets. So this was an early experiment in the biodynamic design. In fact, all our buildings are experiments to try and advance architecture in ecological design. I started to look into how do we use plants to improve indoor air quality. And so this is the tabulation. On the left-hand side are the list of the internal air pollutants. On the right-hand side are the list of plants that absorb pollutants. So when we designed the conference room for the Australian Embassy, we used peace lily to absorb the pollutants on the left-hand side. In planning we did this building where this time we got vegetation from the inside, stepping up to the top of the building. And this is a building in Korea where we did this, almost the same thing. But what nature does for us is what we call, it provides ecosystem services. In other words, nature creates energy by photosynthesis, it absorbs pollutants, through sequestering, detoxification of human industrial waste. Now, the idea of biomimicry is to imitate and replicate the processes of nature, but it became clear to me that it's not possible for us to use technology to compete with nature, because nature is so vast and it does it by itself without any inhuman intervention. So then the thought was that if you cannot imitate nature, replicate it, you should augment it. It also became clear to me that if you were to augment and use nature to provide ecosystem services, the nature has to be as close to the urban realm as possible. So you should change, for instance, from the left-hand diagram to the right-hand diagram. So it was, we need to bring as close as possible. So the idea was to weave nature with the urban realm. As you can see in the left-hand diagram, nature is the green, and the urban realm is the yellow. And this was the master plan for the island of the Reunion, which is east of Madagascar. And you can see the urban fingers which go out. On the left-hand side is the green spine that collects the vegetation from the waterfront, and we brought it into the inland. And then the urban fingers are being woven in between. And in this way, the urban fingers and the green areas are sufficiently close together within about 30 meters or so that the ecosystem services, the remediation of air, production of photosynthesis, and so forth can benefit both the green and the urban areas. So here we are, you can see aerial view of the vegetation that is brought in, and in between are the urban fingers, and so they all meet together. And for the roads going across perpendicular to these fingers, we didn't want to cut the fingers, so we have what we call eco undercroft. That means that the vegetation goes underneath the road, as you can see on the diagram on the right-hand side. Then the edges of the vegetation should not be pristine because species don't like sharp edges. We need to make it serrated so the species can hide, they can, from prey, they can breed and so forth. And so this is the concept. of the vegetation edges. Then we start to look at hydrology, because hydrology is important. When astronomers look up into the skies at different planets, the first thing they look for is what are the signs of hydrology. You said water, if there's water, there's organic life. So this is a master plan for a project that we did in Bangalore, in Bangalore. And the idea was to bring the vegetation from the edges and bring it right across the site. This is the water circulation system. The idea was to close the loop within the buildings, and where it goes outside, we bring it back into the soil, into the ground, through constructed wetland. And these are different ways of doing it, through rain gardens, rain drainages and so forth. But for the black water, we have what we call monoscale, where we construct a wetland where the water goes through a series of ponds, and that with each pond it cleans the black water rather than treating it mechanically as what we're doing now in most of our buildings, in most of our structures. And so here it says we bring the vegetation as close to the buildings as possible and bring it to the edge of the building so that it can connect to other green areas within the same locality. So here the green shows the different vegetation that comes across the site. And where it is bifurcated by roads, we have eco-bridges that links the building, the vegetation on one side to the other side. Now for energy systems, we started looking into how we can design not from existing systems, but to what we call surplus energy. The first approach is to try and use bioclimatic design to create a low energy building without any mechanical electrical systems. And then from there, we lower improve the condition using what we call mixed mode, where we have ceiling fans and side fans. And then, of course, full load would be where the conventional building is. We should try and make it smart systems so that it's low embodied energy and low operational energy. Then you have productive mode where we generate our own energy by renewable resources. And finally, fifth would be where you have surplus energy. So in a nutshell, you can see stages 1 to 5 is a process for designing a low energy building. The first step is really for, especially in the tropics, what we call bioclimatic design, where we use the shaping of the building, the orientation, the facade design, and other features to make it a low energy building. So this was a house that we did a little bit earlier, back in 1985 or so. But the idea was to have a canopy over the building. And this is the canopy at the top. It lets in the morning sun, keeps out the afternoon sun. We got a scientist to measure the temperature. You can see the outside temperatures of 35 degrees. Around the pool, which is about 32. The upper roof is 33.8. First floor is 30.6, and the ground floor is 30.5. And so we were able to use the canopy to lower the ambient temperature, but certainly we cannot get up to 23, 24 degrees. as with any air-conditioned spaces. And so, but by lowering the ambient temperature, we reduce the energy consumption of the building. And the swimming pool then becomes the evaporative cooling device for bringing ventilation to the building, bringing cool air into the building. And we look at the building as context veritas within the surrounding buildings, which were also designed by us a few years earlier. Another canopy approach is this station where we had a series of modules which are linked together. And this is the ticketing space and public space. This was our master plan for the University of Malaya. It consists of photovoltaic, the same printed pattern that we had with the Putrajaya building, but now placed horizontally. And here is the university hub with the contacts. We started looking into the idea of vegetated building, a vegetated roof. This is the design for a complex in India. But mixed mode is where we combine mechanical systems with passive mode. And this is the Ecological Convention Center in the Technology Park. And here we had a roof which is operable. And so this is, you can see the right side of the roof is closed. And here the roof is open. And then the idea was that we could let fresh air and daylight into the auditorium. Now this diagram illustrates the approach in a temperate climate. Well, mixed mode, as I mentioned earlier on, you can see mixed mode. This is mixed mode, is some mechanical electrical systems. So, mixed mode means you use ceiling fans as side-flow fans to cool the space, and sometimes you can use it in conjunction with cool air being blown into the space. This is the plaza where we had huge fans. You can see the one on the right there that cooled the space below without air conditioning. And so the idea was to blow the air down to cool the space, as you can see in the diagram on the left. This was a scheme where the original interior was all air conditioned. The client wanted to have the central circulation spaces non-air conditioned, so you can see the yellow color on the right-hand side are the non-air conditioned spaces, but with the circular ramps, the circular diagrams to show the fans that are used to cool the space with natural ventilation along the sides. But for a temperate zone like the UK, the UK is 32 degrees above the equator. So we had a flue wall installed above an existing glass wall, and there's a valve at the bottom and a valve at the top. That in a temperate climate, the difference between the inside and outside are sufficient buoyancy that the air can be sucked through the flue. This cannot work in the tropics. You cannot use this idea in the tropics because the dry bulb temperature is the same. And so it sucks the air from the bottom up to the top. And that in the temperate zone you have a cold winter and a hot summer. But with bioclimate design you can improve the coffee condition a little bit. But notice it's not equal to the red line, which is conventional engineered interiors. Then with mixed mode, you can further improve the water condition. And with productive mode, you can generate some of the energy. But it's extremely difficult to match consistent temperature, humidity, and air change, as in the red diagram line, because nature is not consistent throughout at all times of the year. So this is the idea of using our climate design mixed mode and productive mode to lower the energy consumption of the building. And of course, productive mode is where you generate your own energy. So this is the data center in Sabitaya, which is completed. Now, to get enough energy from the photovoltaics, just the roof area is not sufficient. So we wanted to generate enough energy to pool, to power the common areas. And so the photovoltaic area has to be at least 58% of the GFA of these areas. To achieve this, we have to push the photovoltaic outwards beyond the facade of the building. And so this explains the shape of the building sticking out to collect the energy. Now the next thing in this diagram, you can notice we have nature, we have hydrology, we have food systems, we have energy. So the next was to look into humans, happiness and society. I thought to look into what makes people happy. And happiness, I found, and I'm working with the neuroscientists, the brain, your brain, our brain gives out hormones, oxytocin, endorphin, dopamine, and serotonin. When we're happy, each of these hormones are released by certain activities, so we start looking at what activities engender the release of these hormones. We start to look at what spaces. And so this became for us like a plan for how to design green spaces to make people happy. Anyway, we're still working on this, it's early days. So I'm going to end in a minute. What you can take away with you. The first is that we need to study ecology. A few schools of architecture teach ecology. Few architects are eco-literate. And so if you don't learn this, then you cannot understand what it means when people talk about climate change, people talk about carbon dioxide sequestering and so forth. And so the curriculum for architecture has to be totally changed to become ecology driven. And then it became clear that we need not just ecology, we have to remake our built environment into constructed built systems. And so in a nutshell, this summarizes what ecological design is. Of humanity on a boat, in a turbulent city, and the boat has a leak. To be rescued, we need information and directives, use equipment. We need to understand ecology as information, and we need to implement biomimicry. So this is the strategy we've got to have in dealing with the environment. And then I mentioned the 5 factors: nature, human society, the built environment, energy, and water. These are different aspects we have to consider in addressing all these factors into a whole system. And then we need to create habitats within our built environment. These are different patterns. And we also need to be aware that nature does many things for us, which is called ecosystem services, such as photosynthesis, production of oxygen, and so forth, without human intervention. And then it also became clear to me that ecological design is not about doing green buildings, but starting with the infrastructure. If your infrastructure is not green, no matter the number of green buildings that we bring into the building city, will ever make a city green. And so green infrastructure is green energy systems, green water, sewage, mobility, and so forth. And so these are some of the factors in designing the green eco-city. And this concludes my talk about how we should save the planet by design. That we need to redesign and make our cities. So green design is not as simple as people think it is. For 2,200 registered architects, and a lot of people graduate and join the market. If there are 11 schools of architecture, and in each school of architecture produces 30 plus graduates, every year we have 333 architects introduced to the market. It's going to be competitive. But it became clear, as I said, architects play a major role because 40% of climate change are from buildings. And so if we don't learn ecology, we don't design for a sustainable future, there will be a future for you or your grandchildren and your grandchildren's grandchildren. And so in many ways, what I'm doing today is a call for action. Like, please look at the design for sustainable future. But it's not easy, it's complex. And those of you who have watched Sesame Street, there's a frog called Kermit who sings this song. It's not easy to be green.
Wow, what an inspiring and enriching presentation. Thank you, Dato, for sharing such a profound perspective on ecological design. We'll now open the floor to questions from the audience. So if you don't mind, please create a line over here. On this side, if you have anything to ask. To kickstart the session, I'll begin the questions from yours truly, me. My question is, in your experience, what are the biggest misconceptions people have about green architecture?
Well, as I said, I think Pam will tell you there are 2,200 registered architects, and there are another few hundred being introduced every year. So it's a competitive business. When you ask any of the 2,200 architects, do they do green design? I'm sure all of them will say yes. But few of them understand ecology, few understand ecological design. And so, as they say, it is greenwash. You just, fake green design. There's a very famous American Chinese architect called Yeang. And Yeang got the RIP gold medal. And So I thought maybe I should buy him lunch. So organized a lunch for Pei and his wife at a fancy Chinese restaurant called Princess Garden in north of Audley Street, north of Grosvenor Square. And so there's Pei, his wife, me and a few other architects. And his wife came up to me and whispered in my ear, "He's nearly 90 years old." I said, "Gosh." Anyway, we talked to Pei and I said, "I hear you from Shanghai. Do you speak Shanghainese?" I said, "No, I'm from Suzhou. I'm Cantonese, and I speak Cantonese." So then eventually the conversation went to architecture. And I said, "I'm a great admirer of your architecture, Mr. Pei." And he says to me, "Ken, what's the architecture that you do?" So to answer your question, I said, "I do green architecture." But Pei's generation don't know what green architecture is. So he asked me, "Ken, what's the green architecture?" Now I've just presented you in the last 40 minutes what green architecture is. But how can I explain to Mr. Pei in a few minutes over lunch what green architecture is? So Mr. Pei, green architecture is 2 coats of green paint. He nodded and said, "Oh, that's good. That's what green architecture is about." Anyway, so my contention, as you can from my presentation today, that green architecture is a lot more complex than what it is, but your schools don't teach it. And that is the biggest problem that I have. So how can you design and ensure a sustainable and resilient future? When architects, you're key people to make the environment green. I'm not aware of this. So what can I do? I can't do very much. I'm not a politician. I'm not an influencer. So the only thing I can do is to show leadership by example through my work, through my books. But I can only do so much within my lifetime. I work, 8, 9 hours a day in my office. I go home, I'm doing research, I'm writing my latest book on ecological design. So my day is full, not just in the daytime, in the weekends as well. So it's important that we, as the next generation, pick up what I do and look into ecological design. So your school of architecture, like your school, needs to change the curriculum. You have to tell the head of school to please change the curriculum to include ecology. Now, not just ecology. What I found very sad is this. The law of averages applies throughout the whole world to everything. There's a law called Pareto's law, called 20% law. I don't know whether you know this law. But Italian economics called Pareto. Well, they discovered a law that 20% gets 80%. All right. So if there are 2,200 architects in Malaysia, 20% means 400 plus gets 80% of the work. Think about it. So the balance of 80% of architects are scrambling to get the balance of 20%. So architecture is a very competitive business. So my first point is that not only should you learn ecology, you should learn how to do business. Because if you don't learn how to do business, you'll be cheated, you'll be manipulated by businessman. So I started business architecture in 1977, long before you were born. And I found at that time that the market share, 70%, was controlled by about 4 major architect firms. BEP, Kumpulan Architect, Team 3, and MAA. They got 70% of the market share. So here's a little guy, Yeang from Penang in Kuala Lumpur. How can he compete? So I did some research and I found that all these big firms, all the principals, King Lu of BEP, Ishama Bakri of Kumpulan Architect, Dato Dr of Team 3, UiTM from MAA, they all, even though they didn't learn how to do business of architecture, they did their business of architecture intuitively. Because they didn't know how to do it, so they did intuitively. So when something goes wrong, they think back, back a few years back, this is what we did, so we should do it again. So I thought, maybe I should learn how to do business of architecture and learn it systematically. And so I started taking courses in 1977 at the Malay Institute of Management, Ecological Management. But once you understand the business of architecture, your approach is systematic, it's not intuitive. Now it doesn't guarantee success, that gives you a sense of direction of what you should do and what you shouldn't do. So that's how I competed back in 1977. At the time, we did renovations for Bank Putra. At the time, CIMB Bank was called Bank Putra. We did renovations of 50,000, 100,000. We did a small factory in Terengganu and a Bank Putra training school in Shah. They could be more than 2 to 5, 8 million. But once I implemented marketing, we suddenly went to a $35 million project. And so that's why learning business is very important. And I recommend schools of architecture to teach their final year students, give them courses on the business of architecture. Then it changes your perception, because as I say, it's very sad when I look at schools of architecture, I see brilliant students which are incredibly talented. They're talented, they're leaders in schools of architecture. They think the same strategy as schools of architecture is the same when they leave. But it's different. You're dealing with a community of sharks. They look at you and they say, you want a project from me? Do your design first. So do design says, thank you very much. You go to another architect, give me design first, you collect all your ideas. The market tells you how to do work for free. So when you don't know, you're hungry. And so you have to be aware of the business world, which is shark eats shark, dog eats dog. And that is why it's so important to learn business. And that's when I did 1977, then I realized that I have to market for business. I have to market for business. There's passive, and there's active, and there's proactive. Passive means to sit and wait for business to come to you. It's so competitive unless you have a shop out in the high street or a shop out in the, in the shopping mall. Nobody will come and give you business. So passive does not work. Then you try active. Active means you go and meet clients and says, give me a project. You go to the government department, you go and says, I need the project. Then the client will say, why should I give it to you? You're a new guy. You have no track record. Give me a free design. And so that's active. And then that's proactive. Now that's the secret. So I'm giving you a secret today. Proactive means you create your own project. How do you create your own project? So passive, active, and proactive. So all of a sudden, with the proactive marketing, I got a project of 35 million. Of course, this is back in 1980, when the development community was just getting going. So I knew some developers, and at the time, this particular client came from Penang and he's looking for projects. And he said to me, Ken, why don't you find me some property I can buy to develop? So that means what it means proactive means you create a project. So I look around and I said, oh, Dato in UK, the land is for sale. It belonged to Bina Credit in Singapore. So I went to Singapore to meet the landowner, Yeang. I said, Yeang, is the land for sale? Yes. Is it approved? Yes. How much do you want to sell it for? So much. I said, can I trade? Can I find you a purchaser? He says, yes. So I went back to the Penang developer and I said, here's the land for sale. I just don't show him the land. I did the financials as well. I said, here's the land, this is what you can build there, this is how much you can sell it for, this is how much the land costs, this is a profit that you can make. Make me the architect, I'll introduce the order to you. I said, okay. I said, you don't have to pay me commission, pay me scale fees. And so from 8 million, I suddenly got a $35 million project at scale fees. This is called proactive marketing. You create your own project. And we found that we became the highest selling thick house in Malaysia. 90,000 for thick house in those days, compared to, let's say, 50,000, 80,000 in C Park or C housing or BJ. So I said, oh, there's an opportunity here. So I started to look around the Ampang area and I found that selling a property owns 81 acres above Tamasu, UK. So I went to meet selling a property and made friends with him. I said, is it for sale? He says, yes. So I introduced it to another friend. So that became my from $35 million to $80 million project. Those of you who live in around that area, we had a book in Tarabangsa. Tarabangsa was created by me. I introduced it to the developer. So by the mid-90s, I was so busy creating this project, I stopped doing that. So these are some examples of proactive marketing. Right? But you wouldn't know that unless you take you learn business. So go and learn business. In the year 2002, I decided there was a recession. I went to Harvard Business School and did a 1-week course. Nobody told me how to do that. I thought I could learn something. The course was called How to Lead a Professional Service Company. The course, like the students, about 30, because in Harvard Business School, the lecture room is a special U-shape. You can sit only about 30 students. And it's a 1-week course, Saturday to Saturday. I did that in 2002, and I said to myself, should have done that 20 years earlier. We learn a lot of things. So learning business is very important. So I recommend to all of you, when you leave the university, go and learn business. And it's going to be tough out there. In Singapore, only 6 to 10% of graduates from School of Architecture in Singapore do architecture. The rest do something else. They work for developers, they work for contractors. So it's tough. So I started to think to myself, and this is very important, why do you want to be an architect? So I ask all of you, why do you want to be an architect? Why is it so stressful to be an architect? There are 4 reasons. The first one is that it is a cash flow driven business. That means you have to do the business first, deliver it, then you get paid. But nowadays, clients are so difficult that it's very difficult to collect fees. So now if you run a restaurant, you sell the food, people eat your food, they pay before you leave your restaurant, but not with an architect. So you just think it's a cash flow driven business. Now when you go to the kopitiam, you guys sell kopitiam. Kopitiam seller takes home 7,000 a month. That's pretty good money. Of course, it's not an easy life. He has to wake up at 6:30, go to the market. He has to go to the market to buy the food. He has to bake it. And he has to spend the afternoon selling. He works 8 hours a day. And if you go around, you can't go around saying I'm an architect. I'm a retail seller, there's no status. But it takes him 7,000. Okay, is it not? You have the car business. You have to sell the car. Then you have to manage the business. Somebody else does the management. You have a car company. And then somebody makes the car. But you as an architect, you have to do all. You have to make the product, you have to sell the product, you have to deliver the product. Right? So you do multiple business functions at the same time. And finally, it is a people business. Your relationship with clients is important. One wrong word, and relationship is gone. Clients are very particular, for so sensitive about money. You ask them for money, this is why you always worry money, then they get angry with you. So cash flow driven, delivery intensive, other business function is a people business. So it's very stressful to be an architect. So you go back and ask yourself, do I really want to be an architect? Lecturers get really annoyed with me. Yeah, I'm teaching architecture, you tell other people not to be an architect. I said, yes. Be an architect if you have a passion for it. That means regardless, you want to be an architect, you have a passion for it. But if you don't have the passion for architecture, it's much easier to sell kway-teow. So that is my advice to all of you students. Right. You want to be an architect, have a true passion for it. Live, if you go to a good school of architecture, if you go to, I went to the AA school in London, and the students treat architecture like a religion. Eat, drink, sleep architecture, like a religion. It's more than a passion, it is a religion for them. Now, if you have that relationship with being an architect, then you can tolerate all the rubbish that comes with it. The cash flow driven, the delivery intensity, and so forth. And so, make sure you have the passion. Your school produces about 30 to 50 graduates a year. How many of you end up in architecture? How many of you have a real passion? that right? Recently. Is that true? He just has to respect himself. He's a heroic figure, you know. I used to work for him in 1976. So I said there are 3 types of architects. We should become architect because there's nothing else to do. First we become architect for money. And second architect who truly believes and has passion architecture, you have to be the third time. You want to pay for the money but nothing else to do, it's better to do something else. You know? Now, he just is as a clever architect. He does many iconic buildings. But if I were to criticize him, if he has 100 projects, he has 100 ideas. Now it's very important to be holistic. That means holistic, the property holism, it means the whole is greater than the sum of its parts. Think about it. You have many parts, but it comes together as a whole. Now if you have 100 projects, 100 ideas, and it's not holistic, then it is not significant. So if you have 100 projects, and they're all interrelated, they all build upon each other, all strengthen the thinking behind each other, then the whole is greater than the sum of its parts. That is organic property. So that's the difference between organisms and machines. Machines, if something goes wrong, you can take it out and replace it. Your wheel, your car doesn't work, you can replace your tires, you can replace the tires, the engine, the part doesn't work. So with machines, the whole is not greater than the sum of its parts. But the biological systems and organisms like you and me, you can't cut off your hand and replace it with another hand. You get a prosthetic hand, but it will not be the same as the one before. And so the whole is greater than the biological property of holism is very important. And then plus your work, all the projects must be greater than the sum of its parts. Otherwise you have 100 projects, 100 ideas. People cannot understand you, people don't understand what you're all about. And so those are the important property. So I'm going to end in a minute. Furukawa. Kisho Furukawa is the architect for the KLIA. I met him back in 1973. There's a very famous architectural critic called Charles Jenks. And Jenks is my friend, he was my tutor. At the time I was living in Cambridge. Charles called me up and says, can you come for tea? I said, what's up, Charles? He said, I've got Mr. Furukawa coming for tea, would you like to meet him? So I met him and came down. In the 60s, he had a group of Japanese architects called the Mentalists. They think the architecture should be like organism, should be like metabolism. And the British architecture community was very impressed. This was in the 60s. They said, oh, maybe the Japanese architects have some quality. So, they published a lot of work on metabolism. But fast forward 20 years, it did not improve. They're still talking about the same thing. So the English are very, very critical. And there is an English newspaper called the Architectural Newspaper. And they did a 3/4-page article on Mr. Furukawa.
Metabolism.
Kisho Furukawa. There's a very disparaging article that says that here, full of promise in the 60s, come to the 90s, nothing has moved. It's fake. Then he said, look at this name, Kisho Furukawa. What is it? It's like opening a cold can of beer. When tissue. Okay, thank you very much.
Okay, taking care of Dato. See you. Bye. You'll be in office. Thank for giving me the opportunity to interview you and also thank you very much.
Nice meeting you too.
Thank you.